Problem 29, we're taking a look at different representations of quadratics and trying to figure out their equation. So for problem A, I have an x-intercept right here at -3 and another x-intercept right here at +1. So if x equals -3, if I think of using the zero product property in reverse, I would move the 3 to that side and get x plus 3 equals 0. Using this, if I did zero product property, I would get that as my solution. So that means x plus 3 is a factor. Doing the same thing with the other one, if I know that x equals 1, moving that over, I get x minus 1 equals 0. So now my two factors are x plus 3 times x minus 1. That is the equation that I have here. That is in factored form. If I want to write it in standard form, I just make a generic rectangle and multiply it out. So x squared, 3x and -x, and -3. So now the equation in standard form is x squared, combine my like terms for 2x minus 3. I'm going to do a very similar idea for problem B. But problem B, I'm given a table instead of a graph. But my x-intercepts are still these values now. It's when y equals 0. So x equals -2 and x equals +2. Moving them over, I have x plus 2 equals 0. And moving that one, I have x minus 2 equals 0. So my equation in factored form is y equals x plus 2 times x minus 2. You might recognize that as a difference of squares. So now if I want to multiply this out, x plus 2 and x minus 2, I have x squared, 2x, -2x, and -4. This time, because it's difference of squares, the like terms equal 0. So the equation in standard form is x squared minus 4.